In this video, we will discuss the problem that is longest consecutive subsequence. Problem says that we'll be given an array of non-negative integers and we have to find the length of the longest subsequence such that the elements in the subsequence are consecutive integers and the consecutive numbers can be in any order. For example, if you will see the very first test case here, so we have been given 1, 9, 3, 10, 4, 20 and 2 in this array. Now in this particular array, if you can observe, so the elements 1, 2, 3 and 4, they are consecutive. Although they are occurring in any order, but they are consecutive here. 1, 2, 3, 4, these elements are consecutive. So the length is 4 for this particular subsequence here. Another subsequence that you can identify is 9 and 10 because the elements 9 and 10, they are having the length as 2 and this subsequence is also consecutive but it has lesser length. Another subsequence is the element 20 itself but the length is 1. So the highest length that you have is basically 4 because 4 is the length of the longest subsequence that is consecutive in nature in this problem. Now how can we solve this problem here? So one of the brute force approach of solving this problem is that firstly we can sort the given array. Now like the array that will be given, it might consist of duplicate elements as well. Now once we have sorted the array, so the elements will look like this. It will be like 1 double 2 double 3 4 9 double 10 and then 20. Now do we want duplicate elements actually? Suppose the duplicate elements were given and when we sort the array, so the thing is that the consecutive elements will come together but there will be some duplicates also that will come together. So in this case we need to maintain another list which can maintain only the unique elements. So let's say I'll declare a list V here and initially I'll put the element 1 and then after that initially I'll put the starting element and then after that I'll check and always whenever there's a duplicate element I'll not push it inside the list. So let's say I'm at 2. Now when I check the previous element, is it same? No. So I can put this guy 2 inside the list here. Then after that I'll be at the next 2. Is it same as the previous element? Yes. So don't push this 2. Then after that I'll be at 3. Is it same as the previous guy? No. So put this 3 inside the list. Now when you're at this 3, is it same as the previous? Yes. So don't put it. Now you're at 4. Is it same as the previous? No. So put this guy inside. Now after that you are at 9. Is it same as the previous? No. Put 9 also. You are at 10. Is it same as the previous? No. Put 10 also. You are at 10. Is it same as the previous? Yes. So don't put it. Then you are at 20. Is it same as the previous guy? No. So put 20 as well. So this is what we have done right now initially. Now after this, initially what will happen here is my counter will be equal to nothing but 0 here and my answer will be equal to 0 as well. Now when I come to this very first starting element, there is no element before it. There is no element before it. So the counter will be 1. Since the counter becomes greater than the answer, I update my answer as 1. Now after that I'll go to the next element that is 2. Now when I go to this element 2, is this element same as the previous is the difference between the current element and the previous element equal to 1? Yes. So this means the elements are consecutive. So update the counter to 2 here because you have seen 2 consecutive elements. So answer will be updated to 2 as well. Then after that you will go to the next element that is 3. When you see 3, so is the difference between the current element 3 and the previous element 2 equal to 1? Yes, the adjacent elements have the difference of 1. So update the counter by 1 more. Counter will be 3 because there are 3 consecutive elements here. So the answer will also get updated to 3 here. Then after this will be at 4. Is the difference between the 4 and the previous element equal to 1? Yes. So basically again there is a consecutive sequence that is continuing. So counter will be 4 here. Answer will also get updated to 4 here. Then after that will be at 9. When we are at 9, is it same as the previous element? No, it's not the same. So you will say that now a new sequence is starting which is equal to 1 here, which is basically having the length as 1 because you have got 9 just now. Okay, understand one thing that the length of the answer is 4 here. The answer value is 4 here. Why? Because we have seen a consecutive sequence 1, 2, 3, 4 which is having 4 length and all the integers were consecutive here. Now after that we started from 9 and since 9 was different than the previous element, so 9 is the starting point of a new sequence. After this what will happen will be at 10. Is it same as the previous guy? Yes. Counter will get updated to 2 because 9 and 10 make the length as 2 for the consecutive sequence here. Then after this will be at 20. Is it same as the previous guy? No. So the counter will get updated to 1 here. Why? Because you are starting a new subsequence here. So 20 is a different guy. Now you can see we have ended the iteration and the answer value is still 4. So the maximum value of the answer that we have is 4 because the length of the longest subsequence which is consecutive is basically 1, 2, 3, 4 and the length is 4 here. I hope you have understood this idea here. Now you can see here the time complexity of this approach will be n log n because I'll be basically first of all sorting this particular given array and then after that I'll be iterating throughout the array elements as well in order to find the length here, in order to find the answer here. Now you can see here initially we'll sort the given array, so we are sorting it. We have a v list because we don't want duplicates here. So that's why we have created a v list. Then after that, we'll insert the very first element of the array inside the v list, and we'll check if the current element is not the same if the current element is not the same as the previous element, then in that case you will add the current ith element in the v list. Then after that, you need to iterate in the v list here by running a loop, and you will check two things. Suppose that initially when you will start off and there is no previous element. Okay, so like in order to access the previous element, my I should be greater than 0, and if the difference between the current element and the previous element is equal to 1, in that case you will update your counter. Otherwise, either you are at the very starting element, then the counter should be updated as 1, or if the current element is not having a difference of 1 with the previous element, then also you have a new subsequence starting, so the counter will be made as 1. And every time you can do what? You can keep a track of the counter. If the counter becomes greater than the answer, update the answer here, and at the end we'll return this answer. So we are sorting the array. That is why it will take order of n log n time. Then we'll be iterating throughout the elements here. So this will take order of n time as well. So overall, this code will have complexity of n log n, and the space complexity will be order of n here, because I'll be using a list v in order to store the unique elements here, just in case if we have duplicates. Can we optimize this a bit more? Yes, we can optimize this approach a bit more by using the hashing concept here. So what I can do is, whatever array has been given to me, I can initially insert all the elements of the array inside a set. Why? So that I can easily check whether an element exist or not. Now whenever I'll be at a particular element, I'll always check whether its previous element is there or not. Basically, if I'm at, let's say, 10, I'll check whether 9 exists or not. Why? Because I want to start from the very first element of the subsequence here. Okay, understand one thing. Initially, what will happen here is, initially I'll be at this element 2. Now, does the previous element for 2 exist? Does 1 exist in the set? Yes, 1 does exist. If 1 does exist, then 2 is not the starting guy of the subsequence. So I'll move forward. Now I'll be at 9. Now, does the previous element for 9 exist? Does 8 exist? No, 8 does not exist. So this means 9 is my very first element. So my j value will be equal to what? It will be equal to 9 here. Then after this, my j value will be equal to 9, and you can see that 9 does exist. Then after this, what I'll do is, I'll check for 10, because if you initially see, I checked for 8. Did 8 exist? No. If 8 did not exist, then 9 is my very first element of the subsequence. So 9 does exist in my set. Now I'll check for 10. Does 10 exist or not? So I'll check for 10. Does 10 exist? Yes, 10 does exist, because you can see 10 is also there. So after that, I'll check, does 11 exist? No, 11 does not exist. So if 11 does not exist, so which elements have existed here? 9 existed and 10 also existed. Now how many elements you have in this subsequence? You have 2 elements here. So initially your answer is right now 0 only. But if you will see here, what is the length that you get? The length that you get is nothing but j minus AR of I. This is the length of your consecutive sequence here. So you can see 11 is the value of j, minus 9 when you will do, you will get the answer as 2, because there were 2 elements that were present. So update your answer as 2, because 2 is greater than 0. Update your answer as 2 now. After that, we'll move on to the next element, that is 3. When I'm at 3, is the previous element existing for 3? Does 2 exist? Yes, it does. So 3 is not the starting point of my sequence here. After that, I'll be at 10. Does the previous guy exist for 10? 9 does exist. So 10 is not my starting guy of a subsequence. Then after that, I'll be at 1. When I'm at 1, does 0 exist? No. So 1 is the starting guy of the subsequence here. So now what I will do is, since 1 is the starting guy of my subsequence, so here what I'm going to do is, I'm going to say that my j will be initially equal to 1, and 1 exists, so j will get updated to 2 here. Okay, you have seen 1 so far. Now 2, does 2 also exist in the set? Yes, it does. Then after that, we'll check, does 3 exist? Yes, it does. Does 4 exist? Yes, it does. So you can see 4 elements have existed so far. Then after that, we'll check, does 5 exist? No, 5 does not exist. So the elements that have existed here in this consecutive series is 1, 2, 3, 4, and after that, when I check for 5, 5 does not exist. So when I'll do what? When I'll do 5, when I'll do ARR of, basically when I'll do j minus ARR of I, I'll get 5 minus 1, that is basically equal to 4, because currently I was at the element 1 and I tried to reach till 5. So 5 minus 1 gives me 4. This means 4 elements were consecutively present. So update your answer as nothing but 4 here. Then after this, what are we going to do? We are going to move forward, and my I index will be here. If your index is here, then the previous element exists. 4 is standing here, like you are standing at 4. Does 3 exist? It does exist. So you cannot start from here. You will move forward. Now after that, you'll be at this particular index here. Now you're at 20. Does the previous element 19 exist? No, it does not exist. So 20 is my starting guy. So 20 will be there. J will be equal to 20. Then after that, I'll check, does 21 exist? No, 21 does not exist. So what is the length here? 21 minus 20, this will be equal to basically 1. So 1 is the length of the consecutive sequence, which is starting from 20 here, because 20 only existed. Now what is the longest length that you have got? The answer is storing the value as 4, because the length of the longest consecutive sequence was equal to nothing but 4 here, because there were 4 elements 1, 2, 3, 4 that were existing consecutively. Now if you see here, the idea is that whenever I am at a ith element, I'll check whether ARR of I minus 1 exists in the map or not. If it exists, this means that the ith element is not the starting element of the the subsequence. But if it does not exist, in that case, we can say that the ith element that I'm at, it is my starting element. For example, 9 was the starting element of a subsequence here because the element before it did not exist. 1 was also the starting element of the subsequence here because the element before it did not exist. 20 was also the starting element of the subsequence because the element before it did not exist. So you can see that overall we are going to linearly iterate only, and the overall number of iterations that you will do will be order of n here only because we'll be iterating throughout the array. Let's have a look at the code also. You can see here, firstly I'll push all the elements in a map or the set here. Okay, you can see that I'll add all the elements of the array inside the set, and initially I have declared my answer as nothing but 0 here. Then after this we'll iterate and we'll check if the for the ith element, if its previous element arr of 5 minus 1 does not exist in the set, this means that my ith element is the starting element for the subsequence. So update your j as arr of 5 and then check if the j exists in the set. Keep on increasing your j. Now you will come out when the jth element does not exist in the set. When you come out, then the length of the subsequence, length of the consecutive subsequence will be j minus arr of I, and you can keep a track of the maximum. At the end, you can return your maximum here like the way I did. Now you might think that this while loop that we have internally, it will take order of n square time, because of this will take n square time, but that is not going to happen. Overall, you can say that the time complexity will be order of n because we'll be iterating throughout all the elements of the array, and then after that, in the worst case, this while loop overall, the while loop overall will take order of n time independently, because if suppose that like there's an array which is consisting of 10 elements and all the elements from 1 till 10 are existing, suppose 4 5 6 7 like 8, and all the elements from 1 till 10 are existing, in that case you will iterate throughout this array as well as your j will iterate from 1 till 10. So in the worst case, this j loop is going to take order of n time overall. So the overall complexity will be order of n here, and the space complexity will be order of n as well, because we are going to use a set or a map to check if an element is present or not inside the given array. Okay, now let's try and submit this code also. So you can see here that I have written the code. Let's try and submit this. So let's try and see if the code will get accepted or not. So you can see that my code gets accepted. I hope that you're clear with the intuition and the logic for this problem. It was asked in companies like Amazon and Microsoft. If you have understood this clearly, make sure to comment understood. Thank you for watching this video.